Okay, we are going to write 25 in these questions. We are going to write 25 in terms of a, and a is given in terms of 10 and 2, because when the logarithmic base is not written, we know that is 10. We are going to try to write 25 in terms of 10 and 2. If we say 25 is equal to 5 times 5, that's going to be equal to 25 is going to be equal to 10 over 2 times 10 over 2, and this is equal to 100 over 4. So logarithm base 10 25 is going to be equal to logarithm base 10 100 over 4. That's going to be equal to logarithm base 10 100 minus logarithm base 10 4. And this is going to be 10 square, and this is going to be 2 square. Here it's going to be equal to logarithm base 10 square minus logarithm base 10 2 square. That's going to be equal to logarithm base 2 times logarithm base 10 minus logarithm base 2 times logarithm base 10 2. Logarithm base 10 2 is equal to a. In the question it is given here, and it's going to be equal to 2 times 10 is equal to 1 minus 2 times a, which is equal to 2 minus 2a. It's going to be okay. What about 18 and 12? Logarithm base 3 18. We are going to write 18 in terms of 3 and 12, or because it's not easy to write 18 in terms of 3 and 12, maybe we can do this one. 18 and 12, they have common factors. What I mean, logarithm base 3 18 is equal to logarithm base 3 9 times 2, which is equal to logarithm base 3 9. This expression is equal to 2 because the power is 2 here, plus logarithm base 3 2. So this is unknown for us here. Logarithm base 312, I'm going to write in terms of 3 and 2 again. It's going to be equal to logarithm base 3 times 4. It's going to be equal to logarithm base 3 plus logarithm base 3 4. And this expression is going to be equal to, here it's equal to a, we know that one, and it's going to be equal to logarithm base 3 is equal to 1. This is equal to 1, and plus logarithm base 3 2 square is going to be. So a minus 1 is equal to logarithm base 2 times logarithm base 3 2. So a minus 1 over 2 is going to be equal to logarithm base 3 2. Why I was looking for logarithm base 3 2? Because this expression can be written in terms of base 3 and 2. Okay, then here if we get this one a bit down, I'm going to continue to this expression. Is going to be equal to here logarithm base 3 square, which is equal to 2, plus this expression, it's going to be equal to a minus 1 over 2. That's equal to 2 times logarithm base 3 2 plus a minus 1 over 2. That's going to be equal to 2 plus a minus 1 over 2, and this is the last part now. 2 plus a minus 1 over 2, 2 times 2 is equal to 4, plus a minus 1 over 2. If I get this part a bit smaller, here this expression is going to be equal to a plus 3 over 2. Therefore, logarithm base 318 is equal to a plus 3 over 2, or logarithm 25 is going to be equal to 2 minus 2a over 2 minus 2a. Sorry. Now we are going to continue with this property. Here in this property, if the logarithmic base and the exponential base, this is the exponential base, this is logarithmic base, and if they are equal to each other, logarithmic base and exponential base, they are equal to each other, what is the argument here? The main part is written as a result. So in this question, if we try to apply the property, here the logarithmic base and the exponential base and the logarithmic base are the same, the answer is going to be equal to directly 8. Here the bases are not same, but these two, they are similar numbers. 25 and 5 can be written, 25 can be written in terms of 5, like 5 square. 5 square times logarithm base 5 and 3. These two in front of the logarithm can be written as a power of 3, so it's going to be equal to logarithm base 5, 3 square. The answer now is going to be the main part, which is the main part here, 3 square. So the answer is going to be equal to 3 square, because exponential base and the logarithmic base, they are equal to each other. So the answer is 9. Here in this question, again, there is multiplication. This multiplication, first we should solve this multiplication problem, and we should get this coefficient in front of the logarithm as a power of 2, and it's going to be equal to 3 times logarithm base 3 2 cube, and that's going to be equal to 3 logarithm base 3 8. This part maybe I wrote extra, and the logarithm exponential base and the logarithmic base, now they are same. By the property, the result, it should be equal to x here. The x value here, it's equal to 8. In this question, we are going to check the logarithmic base. Here, firstly, we should remember logarithm base ex is written as ln x. So e to the power of ln x is equal to e to the power of logarithm base e x, it's going to be. So the answer is, the base here, they are same. The answer is equal to x. Okay, this is the A. What about B? B, the logarithmic base is not written, that's why we know it is equal to 10. So this is 10 logarithm base 10 and 3. So it's going to be equal to logarithm base 10 3. Here the base of exponential and logarithmic base the same, so we're going to replace these values here. It's going to be, and 10, pardon, the answer, there's no need to write anything here, only the answer is, the main part is 3. Okay, the C1, for the C1 here, for the C1, the bases and logarithmic base and exponential base, they are not same, but 4 can be written in terms of 2. So 2 square to the power of logarithm base 2 7 can be written as logarithm can be written log 2 to the power of logarithm 2 times logarithm 2 7, logarithm 2 7, and this is going to be equal to 2 logarithm base 2 7 square. The answer is 7 square is going to be, because exponential base and logarithmic base, they are equal to now each other here. The answer is 49 for the C1. Okay, this is this exercise from the exercises part in your book, and this is the G1, and here the logarithmic base and exponential base, they seem different, but here y can be written 1 over here. For this one there's no problem, x and x, it's same, but here they are not same. This is 1 over y and 1 over y. Here t and 1 over t. Only we are going to solve the problem here. For g, x logarithm x3 plus y logarithm y to the power of -1, 3 to the power of -1. It should be written like this. And z logarithm z 1 over 3 plus, minus t logarithm t to the power of -1, and this is 3 to the power of -1 again. Okay, here the first one is going to be equal to the logarithmic base and exponential base, they are same, so it's equal to 3. Here this one, they are not same now because this is y to the power of -1, and we are going to write the power in front of the logarithm. But when you write in front of the logarithm, the base power should be written to denominator, the main part, the power should be written to numerator. So this is going to be y logarithm -1 over -1 times, logarithm y3 plus z, here we have z and it is same, so this is going to be 1 over 3 directly. The exponential base and logarithmic base is same. Here minus t to the power of -1 over -1 again, this -1 numerator times logarithm t 3. Here this is going to be 3 plus -1 over -1 is equal to 1 y logarithm base y3 plus 1 over 3 minus t and logarithm 3, yes, is going to be. Here the logarithm base t, not 3, logarithm base t to the power of logarithm base t. So this is going to be 3 plus, now this is also the, here exponential base and logarithmic base, they are same, that's why it's going to be equal to 3 plus 1 over 3 minus, here the exponential and logarithmic base, they are same, so this is equal to 3. And if you add them, the answer is going to be equal to 3 and -3, they are going to cancel each other. 3 plus 1 over 3, that's equal to 3 times 3 plus 1, 10 over 3 going to be. Okay, for this question, here it says that the b value and c value, you may change their places. B value and c value, you may change their places. So I can change 2 value and 5 value. When I change the 2 value and 5 value, this expression is going to be 5 logarithm 3 2 minus 5 logarithm 3 2. If this is x, this is also x, what is same here, then the result is going to be equal to 0. Again, I'm repeating the property. In this property, it says the exponential base and the main part of the logarithm, argument of logarithm, can be switched. And here I switched them, C and B. Also in the question, when we switch them, we are going to get the result 0.